Hello everyone, I am Mayank and welcome back to Simplilearn's YouTube channel. Today we are going to explore K-nearest neighbors or KNN, which is one of the most popular algorithms in data science. Python is a powerful tool for data science and KNN is great for classifying data by predicting the category of sample based on its closest neighbor. This algorithm is used in many fields like healthcare, finance and agriculture, helping us make decisions based on data. The best part, it is really easy to use. You just need to pick a number for k and choose a distance function to compare data points. However, KNN has its downsides. It doesn't work well with the large data set and it requires proper scaling of the data to get accurate result. In this video, we will show you how KNN works with real data set. The IRIS dataset will walk you through simple Python code and demonstrate how to find the best k value to maximize your model's accuracy. So stay tuned to see KNN in action. Before we move forward, unlock the future of AI with comprehensive program in collaboration with ENICT Academy, IIT Guwahati. In just few months, you will master cutting-edge skills in generative AI, large language models, and machine learning. From learning tools like ChatGPT and DALL-E to gaining hands-on experience with Python and TensorFlow. This course will equip you to lead AI projects and qualify for top roles like machine learning engineer and data science. Plus, with an IIT certificate on your resume, you will stand out to the best employers in tech. So don't forget to check out the coursing from the description box below and the pinned comment. So without any further ado, let's get started. So welcome to the demo part. So I am here using Google Colab. So you can use any of your favorite IDE like Jupyter Notebook, IntelliJ, Visual Code Studio, anything. Okay. So let me rename this file as KNN Classification. Okay, cool. So let me tell you that KNN can be used for the classification regression predictive problems. So KNN falls in the supervised learning family of algorithms. Okay. So we will measure the distance between the k neighbors, and the first step will be we'll choose the number of k of neighbors. Then we'll take the k nearest neighbors of the new data point according to your distance metric, and the step 3 will be among these k's neighbors, count the number of data points of each category. Okay, step 4, we will assign the new data points to the category where you counted the most neighbors. Okay, so let's start. First, let's import some library. Import numpy as np, and let's import pandas as pd. So everyone knows what is numpy and the pandas. Okay, so NumPy is a library for the Python programming language, adding support for large multi-dimensional arrays. Okay, along with the large collection of high-level mathematical functions. And whereas Pandas is a software library written for the Python programming language for the data manipulation and analysis, all the data frames and data structure it offers for the manipulating numerical tables. Okay, and the time series, you can say. So moving forward, we'll import our dataset. So you can download the dataset from the description box below. Okay, dataset equals to pd.read_csv. The data name is iris.csv. Okay, this is how you read your data in Python. Okay, yeah, dataset is loaded. So dataset dot shape. Okay, yeah, so dataset dot shape is used for how many numbers of rows and columns present in your dataset. Okay, 150 rows and 6 columns. So let me tell you brief about dataset, this IRIS dataset. So IRIS dataset include 3 IRIS species with 50 samples each, as well as some properties about each flower. So one flower species is linearly separable from the other 2, you can say, but the other 2 are not linearly separable from each other. Okay, and this shape, I told you, we can get a quick idea of how many instances of rows and columns are present in our dataset. So let's see our dataset dot head. So head is used for you can see top 5 rows of your dataset using head, And if you will use tail instead of head, you can see the last 5 rows of your data set. Cool. Okay, so columns are ID, sepal length, sepal width, petal length, petal width, and the species. Cool. Then moving forward, let's describe our data sets. So these are the basic function, okay, of Python, you can say. So dataset.describe, what describes do is it will give you count of all the rows, mean value, standard deviation value, minimum value, what is the 25%, okay, of all the values in the particular row, what is the 50%, what is the 75%, what is the maximum is 150, you can say, okay, and 25% of 150 is 38.25, this, okay, of all the columns. If it is normal character, so it won't give you any data. Okay, cool. Yeah, so moving forward, let's now take a look at the number of instances row belong to each classes. Okay, so we will write data set dot group by species dot size. Okay, species S is capital, that's why it's showing the error. Yeah, so you can see iris setosa are 50, iris versicolor are 50, and virginica is 50. Okay, and the data type is integer. Cool. So as we can see, dataset contains 6 columns like ID, sepal length, sepal width, and petal length, petal width, and species. The actual features are described by columns 1 to 4. The last columns labels of samples. Okay, so firstly we need to split data into 2 arrays like X features and Y labels. So how we will do this? By writing code like feature underscore columns equals to sepal length, sepal width, petal length, petal width. Just remember you are writing correct name. Okay, then X equals to dataset feature underscore columns, okay, dot values, then Y equals to dataset species dot values. Cool. Then let me run it. So this is how we can split the data set, okay, into 2 arrays, X and the Y. Okay, in X there are feature columns, these 4 columns are there, and in Y species column is there. Okay, and what is the species column? This setosa, virginica, and all this. Cool. Then now we will do label encoding. So as you can see, labels are categorical. KNN classifier does not accept string labels. So we need to use label encoder to transform them into numbers. Okay. Then iris setosa correspond to 0, iris versicolor correspond to 1, and iris virginica correspond to 2. Okay. 0, 1, 2. Cool. So how can I write? From sklearn dot pre-processing import label encoder. Okay, so what we'll do, label encoder transform them into numbers. Okay, so I will write L equals to label encoder, okay, my bad, label encoder, okay, then Y equals to elifate dot transform Y. Okay, so now I will run it. Yeah, correct. So splitting dataset into training set and the test set now. Okay, so now we'll split dataset into training set and test set to check later on whether or not a classifier work correctly or not. Okay, so here I will write from sklearn dot not cross. I will write here sklearn dot model selection import train test split. So what is train test split? Train test split is a model validation procedure that reveals how your model performs on your new data. Okay, and what is xtrain, xtest, ytrain, ytest in Python? Okay, let me first write it and then I will let you know. Okay, then I will write here xtrain comma xtest comma ytrain comma ytest. Okay, equals to train test split, then x comma y comma test size 0.2 and the random is this. Okay, some error came. Okay, underscore model selection. Yeah, cool. So what is x train, x test, y train, y test? Okay, so x train and y train sets are used for training and fitting the model. Okay, so the x test and the y test are the set used for testing the model, and it's predicting the right outputs label. Okay, so here you can see test size is 0.2, means 80% is for testing, or sorry, 80% is for training and 20% is for testing for the new data. Cool. Yeah, so now we will see some let's do some data visualization. Okay, so here I will write import matplotlib dot pyplot as plt, then import cbon as sns, then here I will write %matplotlib inline. So what is matplotlib? Matplotlib is a plotting library for the Python programming language, and it's numerical mathematics extension. Okay, so NumPy, it provides an object API for embedding plots into application using generating purpose GUI toolkits like Kinter and Python, Qt or GTK. Okay, whereas Cbon is a library for making statistical graph in Python. It builds on the top of Matplotlib and integrates closely with Pandas data structure. Okay, Cbon helps us to explore and understand the data. Okay, so I will run it. Here I will write from pandas dot plotting import parallel coordinates, then plt dot figure size should be 15 comma 10. Okay, then parallel coordinates. Okay, then dataset dot drop, I don't need id, comma axis is 1. Okay, then comma species, then plt dot title and let parallel coordinates plot. Okay, and you can give some font size equals to 20, then font weight equals to, okay, let's say bold only, bold, then plt dot x label, then features comma font size equals to 15, then plt dot y label, then I'll write here features values comma font size equals to 15. Okay, then plt dot legend, then loc equals to 1 comma I will write here frame on equals to true comma shadow equals to true comma face color equals to white, T should be capital, and comma edge color equals to okay plt dot show. Okay, some error is there, plt dot figure size, okay, spelling mistake. Okay, one more error, plt dot legend, okay, face color, okay, some spelling mistake. So yeah, let me make it view output in full screen. Yeah. So parallel coordinates is a plotting technique for plotting, multivariate data. So it allows one to see clusters in the data and to estimate other stat visually. So using parallel coordinate points, are represented as the connected line segments, as you can see. Okay, and each vertical line represent one attribute, and one set of connected line segments represent one data point. Okay, and points that tend to cluster will appear closer together. Okay, so this color is iris setosa, and this is iris versicolor, and this purple one is iris virginica, as you can see in the legend. Okay, cool. So moving forward, let's create another graph, Andrew curves. Okay, so here I will write from pandas dot plotting import scatter. No, it's plotting import Andrew curves. Okay, then plt dot figure. It's AI based, so it's giving me suggestions. Okay, so sometimes suggestions are good, but not always. Yeah, let's carry on. Figure size is 15, 10. Then Andrew curves. Then I will add dataset dot drop idx is species and plt Andrew curves plot. Okay, fine. Okay, let me add. We don't need X label and all. Let me add legend. plt dot legend. Then same LOC equals to 1. Then proposition size. Then I will write here size is 15. Frame on equals to 2, comma shadow equals to true. So this is truly based upon you if you want to add legend or not, or you can skip. If you want to skip, you can skip. Okay, face color equals to white, then edge color equals to black. Okay, then plt dot show. Yeah, so no error is there. So let me first view output in full screen. Okay, so Andrew curves, these are the Andrew curves. Okay, you can see the graph in the curve. So Andrew curve allow one to plot multivariate data as a large number of curves, so that are created using the attributes of samples, okay, as coefficient for Fourier series. Okay, so by coloring these curves differently for each class, it is possible to visualize data clustering. So curves belonging to samples of the same class will usually be closer together and they form large structure. Okay, as you can see here. And this is the legend why we are setting the fore color is should be white, and yeah, and the edge color should be black. Okay, and frame on shadow should be there. You can see the shadow. Okay, like this. If you want to skip, you can skip this part, legend part. Okay, but like it's good to have. It's good practice to have this. Cool. So let's create one small pair plot. Okay, so I will write here plt dot figure. Then I will write SNS dot pair plot. Then I will write dataset dot drop. We'll drop again ID. We don't need. Axis is 1. Then I will write hue equals to species, size equals to 3. Then markers equals to OSD. Yeah, cool. Then plt dot show. It's running. Yeah. So first let me make it to full screen. Yeah. So here pairwise is useful when you want to visualize the distribution of the variable or the relationship between the multiple variables separately within subsets of your dataset. Okay. So here this blue one is Setosa, versicolor, and the virginica. Okay, so these are some graph you can say, or here you can see sepal length. Okay, so green one is virginica and versicolor are almost having same sepal length. Okay, and here are the different types of graphs. Okay, if you don't want to let's say if you don't know how to read this graph, you can use this graph, or you can use this graph. Either you can use this graph. Okay, that's the power of pairwise plots you can say. And the sepal width centimeter. Okay, setosa, no, okay, virginica and versicolor again having almost same sepal width. Okay, and here as well. Okay, this setosa is in different form. Okay, yeah, so we'll create one small pair of one small graph, then we'll move forward. Okay, I will write here plt dot. So now we are creating box plot figure. Okay, then dataset dot drop, then again id comma axis should be 1 dot box plot. Okay, then figure size I chose this. Yeah, let's run it. Yeah, again see, this is the box plot. Petal length same, petal width, sepal length, sepal width. Okay, according to width it is showing, like from this to this width we have the versicolor, and from this to this width, this length, sorry, sepal length, we have that virginica lies here, iris virginica, and from here to here iris setosa lies. Okay, the sepal length. Cool. And like you can use 3D models, you can use different types of charts. Okay, I did 4, and 4 are enough to read the data set. Okay, so now we will do some KNN classification. Okay, we will make prediction and we will see the accuracy of our data set. Okay, so now what I will do, I will write here from sklearn dot neighbors import k neighbors. Okay, write from sklearn dot neighbors import k neighbor classifier. Okay, then I will write here from sklearn dot matrix import confusion matrix comma accuracy score. Okay, then I will write from sklearn dot model selection import cross value score. Okay, so here what I did, we are fitting the classifier to the training set and the loading the libraries basically. Okay, then we'll initiate a learning model k equals to 3. Okay, so here I will write classifier, let me give one space, classifier equals to neighbors classifier and neighbors equals to 3. Okay, then fitting the model, I will write here classifier dot fit xtrain comma ytrain. Okay, then now we will predicting the test set results. Okay, so y prediction equals to classifier dot predict x test. Cool. Okay, from spelling mistake. Okay, yeah, I guess it's fine now. So now let's evaluate the prediction. So here I will build the confusion matrix. Okay, so here I will write cm confusion matrix equals to confusion underscore matrix y test comma y prediction. Okay, then here I will write CM. Okay. So what is confusion matrix basically? So confusion matrix, is a table that shows how well a model performs by comparing its prediction to the actual values. Okay. So what it shows, a confusion matrix displays the number of correct and incorrect prediction of each class in models. Cool. Either it can give you true positive, true negative, false positive, false negative. Either it can give you 0 or 1. Okay. So yeah, moving forward, let's calculate the model accuracy. This is the main part. If the model accuracy is low, it means your analysis of classification is not good. Okay. So accuracy, it should be more than 80 at least. Accuracy equals to accuracy underscore score y test comma y prediction into 100, otherwise it will give me in points. So I will write print model KNN model accuracy is, I will write plus str, I will round it. Okay, accuracy I will add the percent. So why I wrote this accuracy to round? So I don't want after points, I need only 2 numbers. Okay, I don't want like 6, 7, 8, 9, 10, 11, 12 like this. Okay, I need only like 80.20 like this. Cool. Let's run it. See, our KNN model accuracy is 96.67. That's why I wrote 2 here, and the percent should be there. So 96, which is very, very, very good. Okay, so this is how you can find the accuracy. So now let's find the optimal number of neighbors in K. Okay, basically finding the best K. So we will use using cross validation parameter. Okay, tuning. So first I will create the list of K for KNN. Okay, so here I will write K underscore list equals to list range 1 comma 50 comma 2. Here I will create the list of CV score. Okay, so here I will write CV scores. Okay, I have to give the brackets. Yeah. So we'll here perform the tenfold cross validation. Okay, I will explain you what is cross validation. Don't worry. So first, let me write for K and K list KNN equals to K neighbor classifier, and here I will write N neighbors equals to K. Then scores equals to cross value score KNN, then X train comma Y train. Okay, comma I will write here cross validation equals to 10 comma scoring equals to, I will write here accuracy. Okay, and then here CV underscore scores dot append to scores dot mean. Okay, so now yeah, let me run it. Okay, comma some error came. Okay, the error is the scoring parameter. Yeah, why? Because here accuracy you can see, and I did the spelling mistake. Okay, so now what is cross validation? Of course, cross validation determine the accuracy of your machine learning model by partitioning the data into 2 different groups. Okay, called training set and testing set. You can see training test and the testing set. Okay, X and Y. So the data is randomly separated into a certain number of groups or subsets called folds. Okay, you can see the 10 folds we have wrote. Each fold contains about the same amount of. Okay, and there is one more thing, validation. So validation is a technique for assessing the accuracy of the model on dataset. Okay, and this cross validation we did on new dataset. Cool. So now let's find the best k. Okay, so here I will write best k equals to k list. Okay, before that I will write one thing. I will write here MSE was changing to misclassification error. Okay, so equals to 1 as x for x in CV scores. Okay, list I will write MSE dot index minimum MSE. I will use this bracket, square bracket. Okay, so then I will write print the best optimal number of neighbors is %t best underscore k. Okay, let's run it. See, the best optimal number of neighbors. Okay, neighbors is 9. Okay, so in the k nearest neighbor KNN algorithms, okay, so k represent the number of neighbors that are considered when classifying a query point. Okay, see, if we'll classify this particular point, you will get the 6. Okay, 1 2 3 4 5 6. Okay, and let me show you. If you will classify this portion only, so you will get 1 2 3 4 5 6 points like this. Okay, so the best optimal number of neighbor is 9. Okay, so with this we have come to end of this video. I hope you like this video. If you have any question or doubt, please feel free to ask in the comment section below. Our team of experts will help you as soon as possible. And if you want this code, you can comment for the same. Okay, thank you and keep learning with Simplilearn.
Hi there, if you like Simplilearn YouTube channel, similar videos. Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.